Okay, good morning. Welcome to
FamilyMath675.
FamilyMath675. So yesterday we looked at this problem about the number of pairs of parallel edges on a cube, and how did that work?
So the way I did it was look at one edge, and any one edge has 3 pairs of parallel edges, and there are 12 edges, so I multiply by 3, it's 36. And then each pair is counted twice, so we divide by 2, it's 20, it's 18.
Okay, and how did you do it?
Well, there are 3 sets of edges on a cube. There's the edges that go this way, it's like this edge and these edges.
Okay.
The edges that go toward the camera, like that. And the edges that go up.
Okay.
So in each of those pairs, there is 4 choose 2 or 6 pairs of parallel edges.
Okay.
And there's 3 of those sets, so 6 times 3 is 18.
Awesome. Okay, great. So I got an interesting comment on this post from someone named Allison Hansel, and she said, "I'm wondering now, though, how many pairs of parallel lines or parallel edges there would be in a tesseract." What is a tesseract?
A 4-dimensional cube.
4-dimensional cube. Seems like a pretty interesting question.
Yeah.
So before we start to tackle that problem, so before we dive into some calculations, tell me how you would first even begin to think about that problem.
Well, I'd think about it in the same way I did. I'd look at the edges, the sets of edges that go in each of the 4 directions.
Okay.
And then figure out how many edges on the cube, or hypercube, go in that many directions, go in a direction.
Alright.
And I can figure out the pairs in one set, and then multiply that by 4. So there'll be 4 directions.
You think there'll be 4 directions, okay. How about you? How would you begin to think about this problem?
Well, I might do it in the same way because it might be hard to pick out one edge and find out how many pairs there are.
What does parallel even mean in, like, the 4th dimension?
Oh, interesting. Very interesting question. What does it mean in 3 dimensions?
So there
or 2 dimensions. Where is it easy to understand what parallel means?
2 dimensions, probably.
Okay, so what do you think parallel means in 2 dimensions?
In 2 dimensions, it means that the lines never you have 2 lines and they never intersect.
Ah, okay. So in 2 dimensions, parallel means 2 lines that never intersect.
So I guess in 3 dimensions here.
Yeah. Hold on. What do you think? What do you think parallel means?
Well,
in 2 dimensions?
if you have 2 line segments and you extend them into being lines and they never touch, that means they're parallel.
Okay, yeah. All right. So my first question to you is, does that same definition work for parallel in 3 dimensions?
Well, not for sides, because these are not infinitely long lines, but if you extend the sides that you want to see if they're parallel infinitely long and they don't intersect,
okay,
then that would mean they're parallel.
All right. If they don't, okay.
If they don't touch or don't intersect each other.
Okay, what do you think? Does this definition work? If 2 lines never touch in 3 dimensions, are they parallel?
Well, you could have. Well, are you talking about the lines that go on forever?
Yeah.
If 2 lines never touch. Well, no, that does not make them parallel.
Okay, give me an example. Use the cube to give me an example.
So, if you extended this line here and this line here and down, they're not parallel.
Okay.
So then, I guess we have to extend our definition and say that the lines have to both be on the same plane.
Ah, interesting.
They both have to be completely on the same plane, like here or here, like that.
Ah, if you can find a plane that contains the 2 lines.
Contains the entirety of the 2 lines.
And they don't intersect, then they're parallel. Okay, interesting. Any other sort of a different approach to definitions of what parallel would mean? Because even in 4 dimensions, it's going to be hard to figure out if 2 lines are on the same plane.
So if the lines, maybe if you can sort of slide the line, like without rotating the line at all, you can just slide the line.
Ah, okay.
To become the line that you think would be parallel.
Yeah, that's an interesting question. Slide it without rotating it. into each other. Another would be, it's easy to define distance from a point to a line.
They're
You
the
just
same.
draw a perpendicular.
So the
Yeah.
distance would remain
The-
constant.
Yeah, as you move along the lines, the distance between them remains constant. Okay.
Alright.
All right, so let's talk 4 dimensions now.